Hello everyone, myself Dr. Praveen Kumar Balguri, Associate Professor in the Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Welcome to Aircraft Propulsion and Turbomachinery course. In the last two lectures, we have seen working principle and different components and working principle of turbojet engine as well as turbofan engine. In this lecture, we'll see turboprop and turboshaft engines. Before going to the topic, like if you recap, we have seen in this classification of gas turbine, we have seen turbojet and turbofan engines. These two are high-speed engines. When you are comparing with other next two that which we are going to discuss, turboprop and turboshaft. When you are comparing with these two, these are high-speed, high-thrust engines. Among these, we have seen turbojet is among these two, turbojet and turbofan. Turbojet is a high suggested for most efficient at high speeds and high altitude, whereas turbofan is mostly being used by airliners. Purpose is, reason is it is efficient at relatively lower speeds and close to high altitudes or medium altitude, which are usually required for airliners. When you are comparing with turbojet, turbofan is more fuel efficient at moderate speeds, that is close to Mach 0.8 or 0.85. Above that, turbojets are efficient, but turbojet consume more fuel, whereas turbofan is fuel efficient and during that lower transonic or lower subsonic speeds, these are advisable. That is the reason turbofan is mostly used for airlines. And also, if you see this, 100% of thrust is generated by jet exhaust, whereas turbofan 80% of thrust is generated by bypass air. This is approximately 20% of thrust is generated by jet, right? This also we have seen different types like high bypass turbofan, low bypass turbofan, single spool, double spool or multi-spool, and with the reduction gear or without reduction gear. We have seen different types, right? In this lecture, we are going to see turboprop and turboshaft as said. And these two are, if you look at the shown pictures here, these two generate actually thrust by different means. That is, differently when you are comparing with turbojet and turbofan. This is propellers. If you consider turboprop, propellers generates thrust, and which works or rotates or depends on shaft power, right? So indirectly, these two both even same as turboshaft name says. These two engines, turboprop and turboshaft, depends on shaft power, generate shaft power, not directly thrust. Okay. When you are comparing with the turbojet and turbofan, they generate thrust. Here, shaft power, then it will be converted to thrust, that mechanical shaft power. Otherwise, in both the engines, core engine is a turbojet engine, otherwise gas generator, and whatever the energy extracted from the gas generator will be, energy extracted by the turbine will be supplied through the shaft to the either propeller or shaft, which means that that energy will be converted to mechanical shaft power. This shaft power in both the engines. In turboprop, shaft power is used to rotate the propellers. Propellers generates the thrust. Almost 95 almost most majority of the thrust is generated by propeller. Little or a negligible amount of thrust is generated through the exhaust jet in case of turboprop. Whereas turboshaft, 100% shaft power is generated by the shaft only. There is no direct thrust generated by the jet exhaust. So when you look at this jet thrust generated by jet exhaust point of view, turboshaft 0. That is, which means 0 thrust is generated by the gas generator exhaust or jet velocity. Turboprop little, but majority of the thrust generated by propeller. So this is how we can in a way classify or divide to remember the differences between these two groups of families in this classification: turbojet, turbofan, high thrust, turboshaft, turboprop, turboshaft, low speed and relatively low altitude application, right? Turbojet, turbofan are high speed applications. Turboprop and turboshaft. Turboprop driven by propeller. Turboshaft, shaft power will be used to rotate the rotor blades. So turboshaft is the power plant turboshaft is used for rotor blade or rotor crafts, right? That is helicopter applications. So both engines can be used or suggested for low altitude, low speed applications. Because those performance of these blades, this propeller are in this rotates on vertical plane, and whereas turboshaft, that is rotorcraft helicopter blades, rotates in horizontal plane. Both aerodynamic performance of both blades, either in vertical plane and horizontal plane of turboprop or turboshaft, will be limited by the speed. That is, otherwise at high speeds, this aerodynamic performance, these blades will be limited. That's the reason these are being used for low altitude, low speed applications when you are comparing with turbojet and turbofan. We'll see. We'll spend some more time or few more details on these both engines, turboprop and turboshaft. This is just again to recap. This schematic of turbojet engine. Basic components remain same in all these 4 types of engines. That is compressor blades, compressor to compress the inlet air. Then it passes this compressed air to combustors, where fuel will be injected. Combustion will take place, and then high pressure and high temperature exhaust will be passed through the turbines, set of turbines. It depends, either 2-stage turbine or single-stage turbine, and energy will be extracted from this high pressure and high temperature exhaust by the turbine, which will be used to drive the compressor, and remaining energy in the exhaust will be converted to kinetic energy through the exhaust section. And in this case, 100% thrust is generated by exhaust section only, that is nozzle. In case of turbofan, we have seen already, almost components remains the same of the gas generator, except fan. Few are ducted and few are non-ducted fans, and few are located at the rear, before the compressor, and few at the aft of the exhaust nozzle also. That type also are there. Fans at the front of the engine, fans at the back of the engine also are possible. And we have seen, here through this bypass air, 80% of the thrust is generated. Here, approximately here 20% approximately. And we have seen, we have again recapped that different types, high bypass, low bypass, and so on. Different types are there in turbofan. Both are advised for high speed and high altitude applications. And this is the schematic of the turboprop engine. Gas generator remains the same. gas generator components remains the same, that is compressor, combustion chamber, then turbine blades or turbines, right? And here through the shaft, whatever the energy, whatever the energy extracted by the turbine, that energy will be converted to mechanical energy, and then that will be transferred to or supplied to through the shaft to the propellers here. If you see here, right, this is how, through the reduction gearbox, right? So these are the propeller blades. This is the reduction gearbox, and this is the shaft connecting turbines as well as compressors. So there two possibilities are there in every case. This type of engines, either it could be directly connected, whichever the shaft is directly connected to the compressor, then you can directly connect it to the reduction gearbox and propeller. That is one thing. Otherwise, free turbine or power turbine also, that type also is possible. Here another turbine here. This is free turbine or power turbine. It is a power turbine actually, and it is also called as power turbine because it is a main source of the power. Otherwise, it is also called as free turbine because as this turbine will not be connected to to the first stage of compressor, that is high temperature or high pressure turbines. That is the reason it is called as free turbine, which means that primary energy of the exhaust will be converted to mechanical energy and supplied to drive the compressors in this case, and then leftover energy of the exhaust will drive the free turbine, which is not at all connected to this. And of course, two shafts will be there, concentric shafts will be there. But anyway, this first stage of our primary turbine is not at all connected to the free turbine or power turbine. That is the reason it is said it is called as free turbine. And whatever the remaining energy extracted by the exhaust after the first stage of turbines will be used or directly connected to the propellers through reduction gearbox again. Okay. So this possibility, two concentric shafts will be there. Okay. So in which case that means that, for example, if you take first case is propeller is directly connected to the turbine, directly connected to the compressor blades, then turbine. In such case, if you rotate these blades, compressor blades immediately will rotate. That is, core engine part immediately move. That is compressor as well as turbine. That's how we can find after going to the engine practically, physically. If you rotate the propeller, if immediately compressor blades are rotating, that is direct connection, direct to power. Otherwise, in a second possible case, second type is using free turbine, in which if you rotate the propellers, compressor blades won't move immediately. Because this is not directly connected to the core engine. There will be gap actually, loss or gap, because only once the core engine starts and it gets power or energy that is extracted by the turbine, after that only free turbine rotates. Free turbine gets chance to extract the energy, then that only will rotate the blades, right? So in the first case, if you rotate the turbine blade, compressor blades will rotate. In the second type, if you rotate the propeller blades, compressor blades will not rotate because they are not directly connected. They are connected to free turbine, right? Yeah. And gearbox is essential in this type of engine. Reduction gearbox is essential because usually these turbines rotate at a high RPM, and otherwise high RPM and low torque. This reduction gearbox will reduce the RPM. Otherwise, if propellers if it is directly connected without reduction gearbox, propeller can't withstand that loads. That's the point number 1. Point number 2 is aerodynamic efficiency will come down of that blade because of high RPM, forming of shock waves and flow separation. All this aerodynamic through this aerodynamic efficiency will come down. That is the reason propellers, reduction gearbox is installed to make sure that to reduce the RPM, increase the torque. Otherwise, to reduce the RPM, so that propellers rotates as per the design and efficiently and effectively. It can generate, propeller blades can generate thrust, right? So in this type of engine, reduction gearbox is mandatory, right? That is to reduce the RPM. And even mechanically also, such RPMs, these propeller blades are not designed to withstand such loads due to high RPMs at which turbines rotate. That's the reason reduction gearbox is required. It is to make propeller blades work efficiently, actually, but it is at the cost of weight. So reduction gearbox increases the weight. So that penalty is there, but even then, with that penalty also, turboprops are able to are the efficient engines at for low speed and low altitude regimes. And these are the common applications. If you look at civil aircraft, that is transport aircraft, here we can see that is SpiceJet ATR 72700. This is powered by turboprop engine, twin turboprop engines, 2 turboprop engine, which is Pratt & Whitney Canada manufacturer and model is this, and which generates 2750 shaft horsepower. Here, turboprop or turboshaft, the power we don't measure by thrust but shaft horsepower. That is this twin engine equipped SpiceJet. Each engine will generate 2750 shaft horsepower, which is far higher than regular piston engine. At lower weight and better fuel economy. That's the purpose. Piston engines are replaced by turboprop, right? Yeah. And the bottom one is GE-H80 turboprop engine, which generates 800 shaft horsepower, which is used for personal, business flight and few naval applications also. Moderate speeds or low speeds and low altitude applications. Yeah, and in this turboprop engine, so propeller performance plays a vital role. Propellers, so it's good to have some knowledge on terminology or some design aspects of propeller. So propeller are designed or installed in this engine to convert shaft horsepower, shaft power, which is generated by the core engine, to the thrust, right? So you can have a look on this different components of propeller. That is, this is the blade, and this is called tip, and this is root, and this is leading edge, and this is trailing edge of the aerofoil section. So leading edge and trailing edge, yeah, and this is the root or hub, and this is the shaft, right? These are some terminology about propeller, and this rotating propeller blades. It is like rotating wing, actually. This generates geometry of this will be in aerofoil configuration. It generates lift. That lift will be converted through the propeller as thrust. Lift will be converted as thrust here, and a tip rotates at high RPM. Usually, tip rotates at high RPM, and root rotates at rotates at low RPM, and that's the reason. This is one kind of. This sets one kind of limitation, that is, if the tip rotates at such a way that it is close to sonic speeds, then shock waves forms, and then aerodynamic losses. It has to encounter the aerodynamic losses, and which decreases the efficiency. So for that purpose, actually, to counter that purpose, and automatic changing of blade tip angle, as well as pitch of this also, pitch angle also will be controlled. Basically this is not going to be fixed, because this blade twist, of course blade twist also is there, because at the root, however, the blade is there, and it will not be the same geometry at the tip. So there will be twist angle will be there. That is to reduce the aerodynamic losses at high speeds, and to increase the efficiency, so that at high RPM it can generate more thrust, right? And pitch angle also is one thing to know. That is angle between rotation plane and chord of the blade. Chord of the blade and plane of rotation. If this is the plane of rotation, angle between plane of rotation and chord of the blade is the pitch angle, and which will be set low during takeoff and climb for low speed, and as it approaches climb, and pitch angle will be increased. So now we have seen that up to certain stage, that is till supplying shaft power to the propeller, that is a function of the core engine. But now after that, once propeller starts and propeller receives the power, then working as well as efficiency of the propeller blades is a big concern. That should be efficient enough at different speeds, like and at the same time different altitudes, that is during takeoff and during climb and during landing, as well as during cruise, at different regimes of the flight. This blade should be in a position to work efficiently and generate thrust efficiently. For that purpose, they mostly automatic or variable pitch angle propeller blades will be equipped. So propeller pitch can be adjusted to optimize the performance at various speeds. And few performance related performance parameters of turboprop engine, you can say it's not parameters but points related to performance. Most of the turboprop engines are designed to fly at in this range, 15,000 feet to 3,000, in between 15,000 feet to 30,000 feet mostly, but they are efficient at below 25,000 feet, right? And speeds also 200 to 350 knots, and few high performance turboprop engines like Dash 8Q400 can reach up to or exceed 400 knots. Otherwise, this is special type advanced, but otherwise general range of speed is 200 to 350 knots. And turboprops are widely used in regional airlines for short haul routes, because they offer better fuel efficiency at lower speeds. That is, range is up to 500 to 700 miles. In this range, in this range trips, turboprop aircrafts are being used. We have seen SpiceJet, not only SpiceJet, but that particular all commercial aircraft for short duration, right? They prefer they are using turboprop engines only, twin engine supported turboprop engines, because they are fuel efficient for short duration and lower speeds. Few examples, and of course, few military aircrafts also use turboprop engines. Here, such one is Lockheed C-130 Hercules, that is transportation, and U2 surveillance and early warning purpose. Because surveillance, when it comes to transport and surveillance early warning, both one criteria is possibly low altitude, and another one is obvious one is low speeds. Obvious one is low speeds. When in this scenario, in this case, because now even high speed unmanned air vehicles also being used for surveillance and early warnings, but in this case, especially turboprop is being used for surveillance and early warning system. Not only that, transportation system, because they are efficient in low speed and low altitude operations. And not only that, for military purposes, another one is even they can take off from shorter runways as well. Even they can take off from shorter runways. This makes fit for few military applications where transportation is required, some cargo, and then short runways are expected in military bases. That's the reason turboprops are efficient in this low speed and short range operations. Yeah, we'll have a look at advantages and limitations of turboprop engines. The turboprop engines are more fuel efficient than pure jet engines at lower speeds. Lower speeds in the sense in between turbofan comes, that is around 0.85 Mach, 0.85 such region. So, but little more lower speeds, turboprops are efficient when you are comparing with jet. And they provide excellent short takeoff and landing. That's the purpose we can use even for military applications as well. Not only military, and where short runways runways are there, or bases are there. Such applications also, turboprops are preferable, where little more extra, with better efficiency, little more extra payload can be taken, right? And maintenance costs are generally lower when you're comparing with turbojet. And another one is they are inefficient at high altitudes. This is not advantage, that is a limitation. Yeah, turboprops are less efficient at high speeds when you're comparing with turbofan as well as turbojet. And they are not suitable for long range operations. Long range capabilities are not there. And obviously, again, at higher altitudes and high speeds, the performance will come down. So these are few important points about turboprop. We'll again we'll try to recap few points. That is, in a way, it fills the gap between piston engine and turbofan engine, and it performs better than turbofan in lower speeds and low altitude operations, right? Fuel efficient, easy maintenance, and another advantage is short takeoff in short runways also possible. These are the advantages. So fuel efficient, short takeoff is possible, and in all the way it performs better than turbofan in low speed and low altitude. Limitation will be, as it is propeller driven, as the speed increases, performance will come down, and as the altitude increases, fuel efficiency also will come down. These are the few important points to remember about turboprop. And the next type of engines are turboshaft engine. This is a fourth type in the classification. Here, this is also similar to turboprop because it is directly not at all driven by the core engine, and especially not at all directly generates thrust, but through shaft power. Then in case of turboprop using propeller, here through the rotor blades, right? If you have a look at this schematic, so this is an inlet, these are the set of compressor blades, and these are the combustors, and this is a turbine, high pressure turbine, which drives the compressor, that is to continue to run the core engine, right? And the remaining energy extracted from the or whatever is left in the exhaust will be extracted by free turbine, right? Free turbine or power turbine. So these two are not connected. Here you can see these two are not connected. So that's the reason it is called as free, right? This free turbine again connected through shaft through reduction gearbox to rotor blades, which rotates in horizontal plane. In case of propeller, turboprop, they rotate in vertical plane and generate horizontal thrust. In this case, they rotate in horizontal plane, generates vertical thrust. That is the purpose it is being used for VTOL, vertical takeoff and landing vehicles, right? Remaining everything working or operation of core engine remains the same actually. Here, through free turbine, whatever the energy extracted from the free turbine using reduction gearbox, it will be connected to rotor blades, and these rotor blades will generate vertical thrust as well as little amount of forward thrust also, right? So lift and thrust, mostly vertical and as well as forward, combination of these two. So this makes unique. At the same time, this sets few limitations also when you are comparing with turboprop or other engines, right? We'll see, because same blades generating vertical thrust as well as forward thrust. That is a unique thing. That's what, and that sets of course unique limitations as well in the operation and as well as aerodynamic complexity. Lot of complexity will be there. This is not as simple as understanding propeller or any other wing aerodynamics. That's the reason helicopter aerodynamics is little complex than the regular wing fixed wing aerodynamics. Yeah, few few applications of turbo shaft engines. Sorry, this is turbo shaft or Bell 206B helicopter, and which is equipped with Rolls-Royce 250 C20 turbo shaft engine, which generates 420 shaft horsepower. And another example is well-known example is V20 Osprey, that is Bell Boeing C V20 Osprey. And this is equipped with Rolls-Royce AE 1107C. Each engine supplies 6,150 horsepower. 6,150 horsepower. Earlier one is 420 each engine. Here, this AE Rolls-Royce AE 1107C engine can supply huge horsepower, that is 6,150 horsepower. There are the few well-known applications of turboshaft engine. We'll see a few advantages of turboshaft engine, advantages as well as limitations. These are high power to weight ratio. Turboshaft engine is a high power to weight ratio when you are comparing with piston engine, because if you want to generate 6,150 horsepower by piston engine, you need to have huge piston engine. Otherwise, total our set of piston engines to generate such a horsepower, right? Usually 450, 300 or 250. In that range, we can have common piston engines. That range common piston engines can generate horsepower. Can go up to 1,200 also by combining different types of different number of or multiple piston engines, but which increases the weight. That is a thing. So you can generate same horsepower using piston engines. That is only possible by increasing the number of piston engines, right? Which increases the mass, weight as well as volume, right? Which is not at all advisable for this type of aircrafts or aero vehicles, right? So that's the reason turboshaft engines are being used for this purpose, because they are high power. They have high power to weight ratio, right? And they are smooth and reliable operation. That is, when you are comparing with piston engine, they provide steady power output with lesser vibrations, because piston engine is a complex one and the possibility of more vibration. And in case of turboshaft, they provide smooth and steady output, ensuring better efficiency and durability. And they are compact and efficient design. So turboshaft engines are small, fuel efficient, and they are optimized for rotor power. If you take turbojet or turbofan, they are not at all designed for rotor power. Right? Turboshaft is the only one is designed for optimized for rotor power. Turboshaft and turbojet cannot supply rotor power. They only can get thrust, right? Yeah. So when you're comparing with piston engines to achieve the same horsepower, these are compact and efficient. But when you're comparing with other engines of other gas turbine engines like turbojet and all, these are bit complex, because reduction gearbox is depends on free turbine, then reduction gearbox, then rotor blade. So they are limited actually. When you are comparing with vertical propellers, also propeller blades, this horizontal propeller blade performance, because they need to generate lift as well as thrust, and bit complex when you are comparing with jet engine. But otherwise, when you are comparing with because we should not compare this turboshaft and jet at all, because it is in the family related to piston engines, such a way that that is to generate a horsepower, right? Whereas jet engine and turbofan generates thrust, and these are to generate shaft horsepower, that to rotor power, otherwise thrust by rotor blades, right? So when you're comparing with piston, these are compact and efficient design, and easy maintenance, less vibration, and power to weight ratio is high. But comes with cost, that is fuel consumption. So they consume more fuel when you're comparing with turbojet and turboshaft, and consume more fuel than even than piston engines as well, which increases operation cost, and they are complex, and maintenance also difficult when you are comparing with simple turbojet or turbofan engines. And unlike turboprop and turbofan, turboshaft engines are not suitable for fixed wing aircraft. These are only optimized or designed for rotor blade operations, that is VTOL applications, that is helicopter applications, helicopter tilt rotor applications also, because few hybrid configurations are there. Tilt rotor, that is which are designed for horizontal takeoff, at the same time vertical takeoff also. Tilt rotor, where rotor will tilt, right? So these are the few advantages and applications and advantages of turboshaft. Turboshafts are only suitable for rotor blade vehicles. It only generates 100% generates shaft horsepower, no thrust, no direct thrust from jet engine, and they are high power to weight, but at the cost of fuel, that is fuel consumption, less fuel consumption when you are comparing with any other gas turbine engine as well as piston engine. But they performs well at low altitude, low speed operations. That is the reason these are being used in mostly defense applications or private business applications. So in the defense application, that is it can carry more payload, and good at efficient at low speed and low altitude operation. But again, it is somewhat majority have less endurance as well as less or limited range, right? So this is about turboprop and turboshaft. So far we have seen some important points and working principles, important components, applications of turbojet, turbofan, and turboprop, and then turboshaft. These are the references I used. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.